All right, let's talk about something we see literally every single day, concrete. But have you ever really thought about what's inside it? Because today, we're going to crack open that boring gray block and find a whole world of incredible high-tech science hidden inside.
So let's just start with a huge question. What if all the leftovers from our power plants, our factories, even our farms, what if that wasn't waste at all? What if we could actually turn it into the very foundation of our modern world?
This isn't some far-off sci-fi idea. The answer is already here, and it's hiding in plain sight, right inside the most common building material on the planet, concrete. There's a whole new class of ingredients that's completely rewriting the recipe for how we build.
So, how does this all work? What's the secret? Well, it all comes down to one really cool scientific principle. You could almost call it a pozzolanic superpower. It's what turns these materials into high-performance, powerhouse ingredients.
And that secret sauce is something called a pozzolin. Now, to put it simply, these are materials that are super rich in silica. When you add them to concrete, they react with the byproducts already in the mix to form brand new, super strong cement-like compounds. Basically, they're filling in all the tiny gaps, making the final material way denser, stronger, and more durable, all from the inside out.
Okay, so where do we get these amazing pozzolins? Well, our first stop is the world of heavy industry. This is where the byproducts from some of the world's biggest industrial players are being turned into the stuff of modern fortresses.
First up, we've got fly ash. Just picture this. You capture the superfine powder, the literal ash from the smokestacks of a coal-fired power plant. Now, instead of that stuff just getting dumped in a landfill, it gets a new life as a high-value ingredient that can actually replace some of the cement in concrete. And the kicker? It makes the concrete stronger.
Next up is an incredibly fine powder, a kind of microscopic marvel that's actually born from the manufacturing that powers our digital lives. It's called Silica Fume. This stuff is an ultra-fine, non-crystalline silicon dioxide. It's a byproduct that gets collected from these huge electric arc furnaces used to make silicon metal and ferrosilicon alloys. The key ingredients for everything from computer chips to aluminum.
And here's the crazy part, what makes it so powerful. You only need to replace about 5 to 10% of the cement with silica fume to get this massive boost in strength and durability. I mean, talk about a little going a long, long way. It's a perfect example of a small addition making a huge difference. So yeah, this microscopic marvel is a direct result of the high-tech industry. It's just an amazing testament to how even the tiniest particles from one industrial process can have an enormous impact on another. We're literally turning a waste stream into a source of superior strength. All right, rounding out our industrial trio is a material with a bit of a mouthful of a name, ground granulated blast furnace slag, or let's just call it GGBS. This is a byproduct of making iron in a blast furnace. Once you cool it down and grind it into a fine powder, it also becomes an incredibly valuable replacement for cement. So let's just do a quick recap of the big picture here. You've got waste from the power industry, from silicon manufacturing, and from iron manufacturing, all of it being diverted away from landfills and upcycled into a core building material. It's a brilliant example of what you'd call industrial symbiosis. But it's not just heavy industry that's getting in on the action. Nope. Our next source of strength comes from somewhere much more natural, from the world of agriculture. Say hello to rice husk ash. And it's exactly what it sounds like. It's the ash that's left over after you burn the tough outer shell of a rice grain. Now, these husks are naturally packed with silica, but there's a trick to it. To make them a useful pozzolin, you have to burn them at a very specific, very controlled temperature. This makes sure the silica stays in what's called an amorphous, or non-crystalline state, which is what makes it reactive and useful. But here's the thing. Unlike a factory-controlled product, natural materials can be, well, a little inconsistent. And that's why you have to carefully test every single batch for performance and uniformity. Because if you get the burning process wrong, the ash could actually harm the concrete. It's a great reminder that this is a very, very precise science.
So far, everything we've talked about has been a byproduct, a kind of happy accident. But what if you wanted to design the perfect admixture right from scratch? Well, that brings us to our final category, the engineered material.
This stuff is called Metakaolin. And unlike our other examples, this is no accident. This is a highly engineered material, purpose-built from the ground up to be an incredibly effective pozzolin. And the process is super precise. You start with a very pure type of clay called kaolin. Then you heat it up, a process called calcination, to a really specific temperature window.
somewhere between 650 and 850 degrees Celsius. That heat completely transforms its chemical structure, and finally, it's ground down to an unbelievable fineness.
So what makes Metakaolin so good at its job? It's that incredible fineness. This number, 700 to 900 square meters per kilogram, that's a measure of its surface area. Now to put that into perspective for you, just 1 kilogram of this powder has the same surface area as about 3 tennis courts. It's that enormous reactive area that makes it one of the most powerful pozzolans you can get.
So, we've looked at materials from factories, from farms, and even special engineered clays. What does it all mean? What's the big takeaway when we zoom out?
So why does all this matter? It matters because this is a fundamental shift in how we think about building things. We are literally taking materials that were once headed for a landfill and turning them into valuable resources. We're cutting down our reliance on cement production, which, by the way, is a massive source of CO2 emissions. And maybe the best part of all? This isn't a compromise. We are creating better concrete. It's stronger, it's more durable, and it lasts longer. This is the very definition of building smarter and greener. So the next time you're walking on a sidewalk, or driving over a bridge, or looking up at a skyscraper, just remember this. That humble, gray material isn't just rock and sand anymore. It's a marvel of chemistry. It's a testament to turning industrial and agricultural leftovers into the very fabric of our cities.
And that really just leaves us with one last thought to chew on. We've seen how fly ash, rice husks, and furnace slag can be used to build fortresses. It really makes you wonder, doesn't it? If we can do all this by just reimagining what we consider waste, what other amazing materials are just sitting out there waiting to be discovered? What on earth are we going to build with next?